This is the fourth section in chapter 6, which is all on trig functions. And here we look at trig identities. So we already have a couple of identities from year 12. So one of them is sine over cos is tan. And we've already seen that if you do reciprocal of both sides, you'll get cos over sine is cot. So there are two we've got already. We also had another identity from year 12, which is sine squared plus cos squared gives you 1 for any value of x. That's why we have the three lines, the identity. But if you were to divide everything through by sine squared or divide everything through by cos squared, you'll get two new identities. So if I divide everything in this first one here, if I divide everything by sine squared, I'm going to get 1, because sine squared divided by sine squared is 1. Cos squared divided by sine squared, well, that will give you cot squared, because you'll have cos squared over sine squared. So that gives you cot squared. And then 1 divided by sine squared, well, 1 over sine is cosec, so it will give you cosec squared. Okay, so here's a new identity, and you can see it up in the box in the corner. If we do a similar thing over here, and we take this identity here and we divide everything by cos squared, we're going to get 1 plus tan squared. Just swap the first two terms around, gives you sec squared. Okay, and these are called the Pythagorean identities. They're linked to Pythagoras, and in fact the sine squared plus cos squared that we had from year 12 is linked to Pythagoras as well. You could think of the sides in terms of sine and cos, and using that to work out the lengths of the sides, and then you get these two other identities, and we can use these identities to prove other identities, to simplify expressions, or to solve equations. Okay, and one way to help you remember these identities is that, well, if we can remember this one, if you just put a co in front of each of those, you get the identity over here. So 1, obviously don't put a co in front of that. Co in front of this becomes cotangent cot, and a co in front of this, cosec, becomes that. So if you can remember this one on the right, that will help you remember this one here. So let's try some questions, and we're probably going to be using one of these two identities here. Okay, so first one, prove that 1 plus tan squared is sec squared. So we're just doing the working from what we had, sine squared plus cos squared is 1. So what we're going to do, sort that squared out, we're going to divide everything by cos squared. So if I just write it here, divide everything by cos squared. Okay, if I do that, sine squared over cos squared plus cos squared over cos squared is equivalent to 1 over cos squared, and we're pretty much done. Sine squared over cos squared, tan squared, plus 1 gives you sec squared. Okay, and that's done. nothing more to that, just one step. So if we're going to do part B, I mean, you just swap these two over. It's pretty much done. Part B, so we'll start with sine squared plus cos squared. If you saw a question like this in the exam, probably worth like 1 mark, probably 2 marks really, rather than 1 mark. 1 mark for showing what you're dividing by, 1 mark for simplifying and then getting the answer, so probably about 2 marks. This one we're going to divide everything instead by sine squared. So if we do that, sine squared over sine squared plus cos squared divided by sine squared is 1 divided by sine squared. So that's going to be 1 plus cot squared, and that will be cosec squared, and that's it, that one's done. Yeah, so very easy proofs, those ones. Start with sine squared plus cos squared. Okay, so this example here, 2 bits of information. It says that tan A is minus 5/12, and it says that A is obtuse. Now if we want to find our answer, not only do we need to find the size of sec A and sine A, we also need to find the sign. Is the answer positive or negative? The way we're going to do that is we're going to use this here to work out the size of the answer, and to do that we're going to use Pythagoras. We're going to use a right angled triangle, and we're going to use this bit of information here to find the sign of the answer. Is our answer positive or negative? And the way we're going to do that is we're going to use a cast diagram. So we don't know the size of the angle, we don't know the sign of the angle, and we're not going to do the tan inverse of A to work out what the angle is and work out that way, because you may not necessarily get the right sign for your answer. Right, so part A, I need to work out sec A. Now I'm going to work out sec A actually by working out cos A and finding the reciprocal of it. So let's start by using a right angle triangle. The question says that we have this angle A, and it says that the tan of A is minus 5/12. So I'm not going to worry about the minus for the minute, but I am going to put the 2 sides in. Tan is opposite over adjacent, TOA, and using Pythagoras, that means that this side is 13. So that means that cos A is equal to the adjacent over the hypotenuse, 12/13. But that could be minus 12/13. It all depends where the angle is on the cast diagram, this obtuse angle. So what I'm going to do is draw a cast diagram down here. And we're told that the angle is obtuse. Now where do I find obtuse angles on a cast diagram? I find obtuse angles in this bit here. Obtuse angles are bigger than 90 but smaller than 180, because over 180 they'll be called reflex angles. Okay, now that makes sense. If the angle is here, you would expect tan to be negative because only sine is positive, and it is negative. Now what does it mean about cos? Well, if the angle is here, cos is negative. The only place where cos is positive is here if it was an acute angle, or here if it were a reflex angle. They're the only places where cos is positive. Over here, cos is negative. So that tells me my answer is negative 12/13. So there's my final answer here. We're going to do the same with part B. So part B, sine A. Oh, I haven't finished part A yet, have I? That's cos A. So that means that sec A, which is what I'm looking for, is going to be the reciprocal of that. Still minus, reciprocals don't change the sign. Minus 13 over 12. Yep, and if you remember the graphs of sec and cosec, they don't go between 1 and minus 1. They extend outwards from that, so we would expect an answer bigger than 1 or less than minus 1, which it is. Okay, sine A, right, same thing again. Pretty much going to look the same as the first one. There's my terrible looking right angle triangle. Let's try that again. Like that. Here's my angle A, pretty much the same as the first one. 12 and 5. So that's 13. Just like P4. Let's do that in red. So the value or the size of sine A is, I could have used the first diagram actually. Sine is opposite over hypotenuse, so 5 over 13. Now, is it positive or negative? Let's draw another cast diagram. You don't need to. The angle's obtuse, so that means that the angle is here. Sine is positive. I leave my answer as a positive answer. So there we go. Don't need to do reciprocal or anything like that. And then you could, if you wanted, you could work out things like cosec A, all types of things like that. You could even work out sine squared plus cos squared, 1 plus tan squared. Once you've got these values, then you can do all sorts of things with them. So the two important things is that you start by finding the size of the angle, and then you find the sine of the angle. Another way of doing them, you can use the identities to work these out. Okay, these types of questions where you need to prove an identity. I'm just going to put these up. 1 plus tan squared is sec squared as a reminder, because we'll be using them. 1 plus cot squared is cosec squared. On these types of questions, you can either start with the left hand side, make it look like the right hand side. You can start with the right hand side, make it look like the left hand side, or you can start with both sides and try to get something in the middle. Okay, so what we're going to do with this here in part A, if I started with the right hand side, I can use the difference of two squares but not really get much further. But I can use the difference of two squares here, use some identities. Let's see where we go from there. So cosec power 4 minus cot power 4. Let's factorize that. So cosec squared minus or plus cot squared, and then in the second bracket cosec squared minus cot squared. Okay, so that's step number 1. Now I can use an identity to either get rid of the cosec or the cot, and I'm going to get rid of, because I've got 1 plus cos squared, I probably want to keep the bracket that has the cosec plus cot. I probably want to keep that one. Probably want to try and get rid of this bracket. Now I can do that by replacing that cosec squared with using this identity. Cosec is 1 plus cot squared. That looks promising. Right, so cosec squared theta plus cot squared theta not touching that. But in the second bracket, I'm going to change that cosec squared to 1 plus cot squared theta minus, let's tidy that up, minus cot squared theta. So you can see the second bracket just becomes 1. So that just leaves you with cosec squared plus cot squared. Right, we need to introduce cos somehow. Now, what have we got? Cosec is 1 over sine squared. Might be able to do something with that. And cot is cos squared over sine squared. Okay. We've got a single fraction there, so we want to try and get a single fraction here, put these together. So 1 plus cos squared. So we've got the right denominator over sine squared. All right, well, sine squared is cos squared, is 1 minus cos squared. Let's write the identity out. So sine squared plus cos squared is 1. So you can rearrange that and get 1 minus cos squared. So there we are, we're done. 1 plus cos squared over 1 minus cos squared. Done. Okay, right, let's have a look at B over here. Right, I always tend to like to start with a more complicated looking side and make it look easier. And I think on this one, the more complicated looking side is this bit over here, because we can start by expanding brackets. So if I expand brackets, I get sine squared plus sine squared sec squared. Now sec squared is the same as 1 over cos squared, so I could actually write it down here. Now what you'll see is that this bit here, okay, so I'll just write down that's basically sine squared times by 1 over cos squared. That what I've written down there is basically tan squared. So I've basically got sine squared plus tan squared. And we want to get to sec and cos. Okay, so we've got some identities we can use. So basically, sine squared is the same as 1 minus cos squared. So we get the cos squared in there. And tan squared is the same as sec squared minus 1. So that gets the cos in there and the sec in there. So you should always be like looking ahead, seeing, you know, what do you want? Where do you want to get to? So the way that we're doing this question is we're going from here to here. We're going from the right hand side to the left hand side. Now if I just expand the brackets, then the ones cancel out and I'm just left with sec squared minus. So the last one, the slide changed too quickly, finished off as sec squared minus cos squared. Yeah, so you can flip back and so you can see how that finished off. So right, identities again up here in case we need them. And we want to solve an equation. So anytime we want to solve an equation, we want the same terms in it. So it needs to be all cos, all sine, all cosec, all sec, whatever. Or it needs to be something we can factorize. So I've got this cosec squared. Right, I can change that to 1 plus cot squared, and I reckon I can get some sort of quadratic. Right, so let's change this cosec squared using the second identity to 1 plus cot squared. So I'll get 4, 1 plus cot squared minus 9 equals cot. So that's 4 plus 4 cot squared minus 9 minus cot equals 0. So let's make it look more like a quadratic. 4 cot squared minus cot, and then we've got 4 minus 9, which is minus 5, equals 0. Yep, so at this point we might say let x equal cot theta. So then we're trying to solve this quadratic. 4x squared minus x minus 5 equals 0. So at this point we could then use our calculator to find the solutions. Don't know if that factorizes or not. It may or may not factorize. Let's try it. I think let's try factorizing it. If not, we'll use the quadratic equation. So we're going to have well, it could be 4x or 2x. So let's try 4x and x. 4x squared. Oh yeah, I think we can get it to factorize if we put a minus 5 here and a plus 1. 4x squared plus 4x minus 5x minus 5. Yeah, that works. Fantastic. Right, so from this we're going to get 4x minus 5 equals 0. So 4x equals 5. So that means that x is 5 over 4. Over here we're going to get that x is negative 1. Okay, from there we can say, right, well, cot theta equals 5 over 4. So cot theta equals 5 over 4. We probably want to work with tan theta because we've got tan button. So tan is 4 over 5. And then the other value, cot theta, is negative 1. And that also means that tan theta is also negative 1. Reciprocal of negative 1 is negative 1. Okay, so from this point we can use our calculator to find the principal solutions, then a cast diagram. Right, so let's start with the tan is 4/5. So tan of the angle is 4/5. So that gives, we're in degrees. If you look at the range that our solutions are going to be, 0 to 360 there. So I'm in degrees, and I'm going to do the tan inverse of 4/5, and that gives me 38.66 degrees. So 38.66 degrees, and for the tan theta equals minus 1. So if I do the tan inverse of minus 1, or negative 1, sorry, I'll get minus 45, negative 45 degrees. Right, so let's use our cast diagram and work out what these are. So the 38.6 or 38.66 over here. Are there any other solutions? C-A-S-T. We've landed in the part where they're all positive. Where else is it positive? Over here. So that's going to be 180 plus 38.66. So I'll write all of these down in a moment. And then for the other angle, which was negative 45. Let me be a rebel and put this on the same cast diagram. 45 degrees, I'll do it in a different colour. So, like that, there's my 45 there. That means there's going to be another one over there. So, let's do it colour coded. So that means the other solution is going to be 180 plus 45. So all our final solutions, theta, oh actually no, that last solution was negative 45, and negative 45 is here, where cos is where we're doing tan, where tan is negative. Where else is tan negative? Over here. Well, I almost got caught out on that one. So actually that other angle there is 180 minus 45. I almost got caught out on that. So final answers. We want answers in the range from 0 to 360. So we have our first one, 38.66. 38.66. Then we have 180 minus 45, which is 135. Then we have our 180 plus 38.66, which would give us 218.66. And then the last one is going to be this minus 45, which will change to 360 minus 45, which will be 315. So here are our final solutions. Maybe I should have done it on two separate cast diagrams. Okay, you should now be able to do exercise 60 on page 156.